Hello everyone, myself Nishant Kumar Karn and I am a second year undergrad student from National Institute of Technology, Agartala. We are back again with some really interesting questions from the previous year examinations of JEE Advanced and JEE Mains from the topic ray optics. So let's get started. So as you all heard, today we are going to solve a question from the topic ray optics. So let's see the question what it says. The question came in IIT JEE 1999. So what it says is the XY plane is the boundary between two transparent media. Medium 1 with Z greater than 0 has a refractive index of root 2 and medium 2 with Z less than 0 has a refractive index of root 3. A ray of light in medium 1 is given by a vector this A equal to this is incident on the plane of separation. Find the unit vector in the direction of the refracted ray in medium number 2. So what this question says is we have a situation something like this where XY plane is acting as an interface between two medium. XY plane actually separates two medium. Above the XY plane we have a medium with refractive index root 2 and below this XY plane, that is for Z less than 0, we have a medium with refractive index of root 3. A ray of light given by the vector A, this one, is incident on the XY plane. That is, this ray is traveling from medium 1 to medium 2. Then certainly it will be, moving towards the normal as it is traveling from a medium of lower refractive index to a medium of higher refractive index. So it is basically traveling from a rarer medium to a denser medium, and hence the refracted ray will move towards the normal. So we need to find out the vector notation of the refracted ray. We need to find out the unit vector which will be able to represent the refracted ray, which will be giving us the direction of the refracted ray. So the situation can be given something like this. We have A given by 6 root 3 I cap, 8 root 3 j cap and minus 10 k cap. This is basically the vector A, that this is basically the incident ray. So how do we write it? If we see this figure, then vector A can be given as summation of vector PQ plus vector OQ, QO, where QO is 6 root 3I plus 8 root 3J. This 6 root 3I plus 8 root 3J, that is the vector on the XY plane. And here we have minus 10 k cap, that is along the direction, along the negative Z direction. Now the summation of these two vectors can be given as vector A. Obviously vector PO is the incident ray and vector PO can be given as summation of vector PQ plus vector QO. So we can give it like this. We can write the vector A like this. Now the angle made by the vector A with the Z axis can be given as the Z component, cos inverse of the Z component of vector A divided by vector A. This one, if we see this triangle, then the angle made by this vector with the Z axis can be given as, if we assume theta to be the angle between this vector and the Z axis, if this is the angle theta, then as the Z axis is parallel to the line minus 10 k cap, then the angle QPO will also be theta. So basically we need to find out the angle between the minus 10k and vector A. That will be the angle of incidence. Why? Because as this is the angle of incidence, here the angle between vector PO and the Z axis is theta, and as the Z axis is parallel to minus 10k, so alternate interior angles, angle QPO will also be equal to the angle of incidence. So if this is theta, then cos theta will be equal to the base, that is 10k, that is the z component of vector A, divided by the hypotenuse, that is the total vector A. So here we can write angle I is equal to cos inverse of AZ divided by A. So putting all the magnitudes, we get the angle of incidence as 60 degree. So 60 degree is basically the angle of incidence. Now here this vector, यहाँ पर हम लोग एक चीज अज्यूम कर सकते हैं. अज्यूम क्या, थोड़ा सा यहाँ पे दिमाग लगाना पड़ेगा. अगर यहाँ पर हम लोग देखें तो ये जो एंगल ऑफ इंसिडेंस है, ये जो इंसिडेंट रे है, वो बेसिकली किस प्लेन में है? इस वाले प्लेन में. वो प्लेन जिसका एक एक्सेस क्यू ओ क्यू डैश होगा और एक एक्सेस अपना जेड एक्सेस होगा. तो अगर हमारा इंसिडेंट रे उस प्लेन में आता है तो रिफ्रैक्टेड रे भी उसी प्लेन में होगा. अगर हम लोग यहां पर देखें, इफ वी सी हियर, देन दिस वेक्टर ए is in the plane which has one of its axis as QOQ dash and the other axis as the Z axis. So therefore the refracted ray will also be in the same plane. The angle of the incident ray and the refracted ray both must be on the same plane. So as this incident ray is on that plane which has one of its axis as QOQ dash and the other axis as the Z axis, then the refracted ray will also lie on the same plane. It can be better understood by this diagram. Here we have the plane where one of the axis is QOQ dash and the other axis is the Z axis. So as the incident ray is in this plane, the refracted ray will also lie on the same plane. Now we have one of the unit vectors given as k cap. For this particular plane, we have one of the unit vectors as k cap. So we need another unit vector along the axis QOQ dash. We need another unit vector along the axis QOQ dash. So how to find it? We have the vector QOQ dash as, if we see here, the vector QOQ dash can be given by 6 root 3i plus 8 root 3j. The vector QO can be given as 6 root 3i plus 8 root 3j. So if we find out the unit vector of QO, that will be the same as the unit vector of QOQ dash. The unit vector of QO will be the same as the unit vector of QOQ dash. So thus, vector small q can be given as vector QO divided by the magnitude of QO. So this will be the unit vector along the direction of QOQ dash. So now we have the unit vectors for this axis as well as the unit vector for this axis, the Z axis. Now we have the angle of incidence, we have the refractive index of both the media. Now we need to find out the angle of refraction to find out the unit vector in the direction of the refracted ray. Angle is one of the most important things while dealing with vectors. So we need to find out the angle of refraction. So from here we can see from Snell's law, using Snell's law, we can find out the angle of refraction to be 45 degrees. Now let R be the unit vector in the direction of the refracted ray. We have capital R as the unit vector in the direction of the refracted ray. That means this ray can be given as capital R. Now, if this is the angle, small r is the angle of refraction, and we need to find out the unit vector. Unit vector means the magnitude of r will be 1. So to find out the unit vector, we can write capital R in terms of the components along the QOQ dash axis and the Z axis. So from the diagram, we can see the two components of R can be given as Q sine R minus K cos R. We have the value of Q, we have the value of R, small r, we have the value of K. So putting all the values, we can find out that the unit vector along the refracted ray can be given as this. So this is basically the answer for our question. So thank you, future rock stars. That's all for today. We will be coming with more interesting questions in the upcoming videos. So till then, bye bye, take care, and Jai Hind.